Yes children, welcome back to Chemistry Wala classes. This is Satish Kumar. In this video I am going to talk about saponification and cleaning action of soap. Saponification and cleaning action of soap. So first of all, what is the meaning of saponification? I will tell you. Very simple children, the clear definition we have, that is alkaline hydrolysis of triesters to produce soap and glycerol is called saponification. Saponification is nothing but soap formation reaction or soap making process. So alkaline hydrolysis of triesters to produce soap and glycerol is called saponification. So this is the definition. To prove this definition, we have one equation. The equation is, so I am writing here, H2CO C double bond O C17 H35, HCO C double bond O C17 H35, and H2CO C double bond O C17 H35. So COO group, COO group, COO group. So we can call this is triester, and this is reacting with 3 moles of sodium hydroxide which is dissolved in the water. So we can call it is alkali and dissolved in the water. So the products are 3 moles of C17H35 COONA plus we have here H2COH, HCOH, H2COH. So here this is called a soap molecule, and exact name is sodium stearate. And here the byproduct in this reaction is glycerol. So we can call propane 1, 2, 3 triol. This is the exact IUPAC name for glycerol. So triester is reacting with alkali and we got soap as well as glycerol. This is the exact equation for saponification. Then you need to remember here C17H35 COO minus Na plus. So this is the soap molecule. So in this soap molecule C17H35, this is called hydrocarbon part, which is called hydrophobic. Hydrophobic means water hates, it does not react with water, so water hates. And COO minus Na plus is called hydrophilic part, which is called water likes or water loves. And C17H35 hydrophilic part is anotherly called non-polar because it doesn't have plus and minus. But hydrophilic part of soap molecule is called water likes and as well as polar because it has minus and plus charge. So this is exact structure for soap molecule. Then what is the meaning of cleaning action? The cleaning action of soap. Cleaning action of soap. Very simple, children. For example, while eating or when we attend any party, unfortunately the oil of curry falls on our cloth while taking the food, while taking the curry. So the oily part fall on our shirt or cloth. Then how can we remove that oily or greasy particles from the cloth? Very simple, by applying soap or detergent. So on the oily dirt we will rub the soap, and automatically the oily dirt or greasy dirt will be removed from the cloth. Then that is called cleaning action of soap. But it can be explained by with the help of experimental way. That is, this is the oily dirt on our cloth. So when we rub with detergent or soap or any other, around the oily dirt the soap molecules are going to join in a spherical way. So this is called micelle. On the oily dirt, nothing but around the oily dirt the soap molecules are joining in a spherical way. This formation is called micelle. And when we rub with soap on the oily dirt, that will be cleaned out. But you need to remember what is the meaning of micelle. The definition is spherical aggregation of soap molecules. The spherical aggregation of soap molecules around the oily dirt is called micelle. So this is what the cleaning action of soap. So around the dirt the soap molecules are joining and forming a spherical aggregation which is called micelle. But you need to remember here, that is, this is the oily dirt. Oily dirt nothing but that is hydrocarbon, which is called non-polar. So with this oily dirt, the non-polar part of soap that can be react. It means C17H35 is going to react with the oily dirt. Why? Because oil is non-polar and C17H35 also non-polar part from soap. So you need to remember non-polar solute, nothing but non-polar particles dissolves in non-polar solvents. It means non-polar particles dissolves in non-polar solvents. It means C17H35 is non-polar solvent and the oil is here non-polar particle. So non-polar should react with non-polar only. And as well as in the soap molecule we have polar part which likes the water. That polar molecule or that polar part of the soap react with water. For example, this is the polar part of the soap. This can be react with water because COO minus Na plus, we have two poles, positive and negative, so it is called polar. Then the polar should can react with polar solvent, that is water. Water is polar solvent. Why? Water is having H plus and OH minus. So in this way the soap molecules are joining around the oily dirt or any other greasy like dirt particles on the cloth. So in this way you can explain cleaning action of soap and micelle formation. Along with this, I want to tell you three acids formulas which are very important in the soap making process. One is C17H35 COOH, which is called stearic acid, and the second one is C17H33 COOH, which is called oleic acid, and the third one C15H31 COOH, which is called palmitic acid. So these three acids are very important to make the soap. And here you need to remember, in the board exam they will ask you define saponification and explain cleaning action of soap. So first of all, definition: alkaline hydrolysis of triesters to produce soap and glycerol is called saponification. Along with equation, if you write, you will get impression. Then cleaning action of soap. In the cleaning action of soap, first of all we need to explain two parts from the soap molecule. One is polar, second one is non-polar. In that way we can give the definition for micelle and the answer will be done. I hope you got it. Thank you.